Hey, it's Mike. So I've got a special project I want to share with you today that's coinciding with just a small release on my website. I'll have three of these available. The face model in the Lineage series with a set of NKT transistors. So for those that don't know, the original fuzz faces would have come with a couple of different transistor sets, but the germanium set would have likely been an NKT 275. It's probably the most famous set. They're really hard to come by these days, but I found something that I think is really similar spec wise as far as the gain and leakage goes. Also, the same parts package, so they look the same, different part number. This is a military spec version, and they sound really great. They're spec perfectly for a fuzz face. So I really wanted to do just a small run. I'll have three of them available if they're not already sold on my website. So go ahead and you can check the link below and you can check that out. If it is sold out, I have a few transistor sets left that will work. So just let me know if you wanted to grab one otherwise, and I can probably work something out for you. But today I thought we'd just go through kind of the build process, um, part selection, and kind of what it takes to make the fuzz face sound good, I think, and go through a little bit of the history and show you the build process, and we'll go through the transistor selection. So I've got everything ready to go to tune the transistors. I've got my Telecaster and I'm plugged into a high watt DR20. I've also got these tools. So I've got a multimeter here that's set to DC volts. I've got this is an Atlas DCA 55 that what it does is it'll measure several specs of each transistor, and I kind of need to know a couple in order to sort them into kind of piles. So I've got two piles here. One, I know I've kind of pre-sorted these into higher gain and lower gain, and then I've got the test box here. It's kind of like an inside-out pedal, so the circuit and everything is outside, and then all the wires go inside. This is just on an old enclosure that was like a failed project. It's got an on-off switch here, just a toggle, and then you've got your bias, fuzz control, volume control. Bias is for Q2, so the higher gain pile here, these are all going to be Q2, and then you've got the bias control uh, on the signature series would be on the outside on like the truth fuzz, but on the lineage series it's on a trim pot on the inside. Either way, I have something I can dial in the bias for Q2 with. For Q1, I use a resistor. I try to use just the stock value if I can, which is what's in here now. And this is just two clips that are going to where the resistor would be on the board. But I've also got a few values of resistors here, just because that Q1 voltage, there's a window you kind of want it to be in, and a lot has to do with kind of how it feels um, on the attack. It's kind of partly why silicon and germanium fuzz faces feel a lot different. If you get the voltages really the same on both of them, it's harder to distinguish the difference. But silicon tends to bias with the higher voltage on Q1, where germanium has some leakage. It tends to bias lower voltage, and it kind of feels softer on the attack at lower voltage. If you were to bias at higher voltage with a lower leakage transistor, it can feel a little harder. Sometimes that translates into like a brighter sound because of what you're feeling on your pick attack. Anyway, I've got everything here. Um, but we'll go ahead and go through a few things. So what I usually will do is I will just go ahead and measure transistors. You have to be careful with this. Just not touch the body of the transistor. These are pretty reactive. These old like 60s germanium transistors. If you were to touch the transistor, it will leak more, and your gain and leakage measurements will be off. So this one says 33 is my current gain. That's too low. So I'm gonna go through a few of these and just see if I can find one. What I'm looking for is something kind of between 50 and say 70 HFE. For like the classic bus face, you could use lower or higher. This one is 73, so I'll put that in our um, possibly good pile. I'll check the leakage as well. Looks like if it's under point, so let's say 250 milliamps, I would say that's probably good for a fuzz face. If it's higher than that, it's not going to bias very well, and it'll be trickier to keep it stable. It'll kind of the really leaky transistors tend to be more reactive with heat. So see if I just get a couple of good candidates for a Q1, then we can kind of go from there. This one's also 73. We'll put both of these aside. So I've got two here that I think could be good candidates for Q1. Go through this pile, just higher gain. And we'll try to see what I can find closer to, well, just over 100, probably under 120, not too high gain. This one is at 98, so real close. We'll just that one aside. Ultimately, I'm going to be kind of touching the transistor, so the reading's not going to be exactly perfect, but it'll be close enough to get us in the ballpark for now. 109, so this one's pretty much perfect. A little bit more leakage than I want, but I was just touching it. But what I'm going to do is I'm going to put it in the board here, my little test box. I'm just going to let it sit there for a little bit, and I'll put the Q1 where that needs to go. And I'm just going to let it sit there for a little bit, and we'll come back to it, and we'll get the readings. You could use like little tweezers or just something to where you're not touching the transistors as much. I don't like the sockets as much. It was just a quick idea to throw together this test box with a PCB with these little sockets on the outside. It works, but I think my other test box for like a Mark 1 or a Zonk, I've got just some speaker connectors, and it's a little faster to get in and out, so I'm not holding the transistor as long. But what I'll have to do in this case is I'll just have to let it sit for a little bit, and I'll do this for really every buzz face that I do. Just let it sit there for 5 or 10 minutes. It also helps to just kind of play it a little bit, and then we'll get some readings on the transistors. So we'll be right back. The transistors have been sitting now for about 5 minutes, just in the test box. We're close to 4.5 volts on Q2 without really having to do anything. The bias is set around the stock value, pretty close. Q2 is hooked up to this with just the meter is hooked up on like little clips, so I can do that hands free. We can adjust the bias with this, but you can see we kind of are limited because the pot value on this is 10K. Stock value would be around 8K, but this only puts it down to about 4.6 volts. In the Lineage series pedals uses a 25K pot, so it would actually be a lot easier to dial that in. You'd have more range. You'd be able to throw the voltage a lot farther down. You could also gate a transistor with that pot. So with my test box, though, I'm really just trying to get the best fuzz face sets of transistors with closer to stock value. So at some point I might change this to 25K, but the 10K pot works just as it is to give me an idea of where the voltage is for Q2. But ultimately it's adjustable once it gets into the pedal. However, I still will need to adjust Q1 a little bit. So Q1 right now is at 0.52 volts, really close to where I would want it. Ideally, it would be closer to 0.6 volts or a little over. But I've got the bias resistor hooked up here, so I can change that. I'm kind of doing all of this before I even listen to it, because I pretty much know I like the way that these transistors sound. After that, it's just nailing the voltages for the transistors to get the sound where you want it to be. So 0.63 volts on Q1 is perfect. And if we go back to Q2, now you can see the voltage change. Anytime you change Q1, it will affect Q2 based on how they're hooked up. But I've got the trim pot here, or the bias pot in this case. I can adjust. Since it's lower now, I can actually raise the voltage up where it needs to be. And this is set a lot closer to where it would be stock, so close to like an 8K resistor, where the bias is set now. And just a little lower resistor value here, the 27K on Q1. But voltages look good now. The fuzz is all the way up. The volume is about halfway. And at this point, I would just listen to it and see what it sounds like. Ideally, it would be smooth, some texture, and it kind of collapses a little bit when you play chords. Single notes should have like a singing, sustained quality. And then, of course, cleanup. With the voltages where they are now, I can tell you it should clean up really well. Germanium should clean up and be soft, kind of a little bit chimey, less so than silicon is, but you get a little more presence in treble. And then, but just overall, a very nice clean tone that's dynamic, and you can dig in and get a little grit if you want. So I'm kind of looking for all these characteristics when I'm listening to it. Let's go ahead and listen to it now. What I'm also listening for is just the general noise floor of the transistors. Sometimes they can be really noisy, and what you get out of it is kind of like a hissing or a crumpling sound, and I definitely want to weed those out. Now that the voltages are good, and I didn't hear any noise with this set, I would say this set's ready to go into a pedal. So let's go ahead and do that next. I'll go through kind of the whole build process for the Lineage Series FACE model. So let's do that now. Okay, now that we've got the transistor sorted out, we're ready to build up the circuit. So I've got transistors here, and then we've got our the old stock capacitors. I've got just a few here that we'll be using in this circuit. There's 3 caps. You've got your input cap, if this is the output cap, and then you've got the bypass cap for the fuzz control. And you've just got a few resistors and 2 trim pots that we'll use on the board that'll allow you to kind of dial in the voltage and a little bit on how well it cleans up and how much gain it has as well with this input trim control. And it can kind of help rein in some of the low end that collapses. It can be a little bit smoother and less kind of crazy. So something I'll also include with the transistor set that this came with, this little card came with the transistors. So it has like all of the manufacturing information about it on one side, And then on the other side, it's got just some specs for each transistor. I'll send this with the pedal. The circuit board that I'm using on all the Lineage series faces, as well as the Bend model, they're kind of reminiscent of the original fuzz face layout. It's pretty similar. A couple of the components are moved around just so that the traces are shorter and the circuit can be quieter. And just has like the solder pads for each potentiometer and the LED and everything built into that. So it's a little bit cleaner and a little bit modernized, but still kind of old style compared to anything really modern. The boxes will be all this blue kind of hammered texture with the white labeling, which I think looks really nice and clean, and somewhat reminiscent of some of the originals that were using a blue color. And I'll be using all these. This is a Zonk 2 knob, but I really like how they look with kind of the logo and the type font on all the pedals. I think they kind of just fit the vibe really well. So let's go ahead and get started building this up. I'm going to just kind of move some stuff around, and as I build it, I'll explain kind of what I'm doing. So let's get started. So first thing we're going to do is we'll put all the hardware in the box. I usually start with power jack on these. Whenever you're building up pedal, or really anything, you kind of want to create an order of operations, because you'll need to assemble things so that they're not in the way of the other things as you're building. So however you find that works best, but I'll just show you how I do it on these. So power jack's installed. Next we're going to do the foot switch. I'll usually put this little plastic washer underneath the second nut and just snug it a little bit. Not very tight, but just enough. It does a couple of things. It seems like you get a little shock absorbing out of that and slightly less foot switch noise, but it also makes the height kind of predetermined of how much is going to stick out the other side. They'll all be the same. Mainly that's why I do it, I think. But foot switch in there, and I'll use this this just little adjustable wrench on the inside here on the foot switch to keep it from rotating as I tighten this, and I'll get it pretty snug. With this, I just use these rocket sockets usually because they don't scratch anything up too much. Haven't had any issues with them so far, but I'll leave a link in the description for those in case you're curious about them. They're not very expensive. I think these are about $15 for the whole set, and they definitely come in handy. Unfortunately, they do wear out. You can see that one's a little bit worn, but yeah, I just have to use them. So next I'll do the input jack, and I'll put this little lock washer on first. I've drilled these holes. They're kind of there's paint on the inside a little bit and the outside. This is powder coat, and I drill the holes just so that there's a little bit more metal on metal, since the circuit and everything is grounded through the enclosure. I just want to make sure I'm getting the best connection possible. So far, that's worked really well on all of these, and they all ground really well. I don't have any weird issues with any of the Lineage series ones so far. And I'll just, like I said, I'll just run a drill bit through. This is already, they come to me pre-drilled and painted and everything, but I'll just run a drill bit through the jacks. If you get a box like this and it has issues, you can try doing that. You can just measure first too, which I used to do a lot on these, but I've so far I haven't had any issues with these. But I used to kind of measure continuity between the ground lugs on the jacks and the box just to make sure before I did final assembly on it. That way I kind of rule that out as a potential issue. So I've got most of the hardware in there. I've got to do the pots next. And I've got to run these little plastic covers on the back of them. So this is the volume pot. It's a B500K. And I use a linear pot here instead of an audio pot for the volume. I just like how the taper works. I think it feels right for the volume pot. But every circuit's a little bit different. Sometimes an audio pot works better for the volume pot, and sometimes a linear pot sort of feels more normal. On these, linear pot seems good. So I get these in here, but I don't tighten them all the way yet. I'll just get them kind of snug because I might need to move them around a little bit when we're putting the circuit board onto the back of the pots, onto the pot lugs. I should also turn on my iron. That way it's ready to go. I'll just run through and we'll do the bypass wiring next for the foot switch and a little bit on the power jack. Just some of the wiring that we need to do off board. Most of the rest of the wiring in these is all just coming from the circuit board itself and then a little bit from the foot switch. And again, it's kind of that order of operations thing. Whatever comes next is really just because it might, if I install this wire, it might be in the way of this solder point here, etc. I'll show you that as we go along. But this is almost ready. We're gonna just put a few things inside. So first thing, got wire for, or the resistor, which is essentially a wire. This is a 0 ohm resistor. So there's no resistance. It essentially is a wire, but what it kind of gives me is a little bit of finished product. I think it looks nicer than just a plain wire, and you get like the little clippings off of it that I'll need. So this little piece that I clipped off of the 0 ohm resistor is going on the foot switch, and it's grounding the input of the circuit when it's in bypass. And what that does is it makes the bypass quieter. So some really old pedals that didn't do that, I think old MXR pedals, old Electro Harmonics pedals, they didn't have great bypass. Believe it or not, there was something worse than buffered bypass. And buffered bypass was really an attempt to try to fix these issues, but there was an issue with quite a few old pedals where if you're in bypass, you might hear some noise. So like if it has an LFO, which is like it's a low frequency oscillator, if it has an LFO on the circuit, like say a chorus, flanger, etc., phaser, whatever, that sort of the sound of that pulsing could leak back into the signal when it's in bypass. So, or in this case, like the gain from the circuit, from the fuzz, may the noise from that may leak back into your sort of bypass tone and make everything a little bit noisy. And if you just ground the input, essentially it grounds the whole circuit. So your circuit doesn't work anymore and it turns off. It also helps with the foot switch popping. So if that's potentially an issue on your build, sometimes that can help fix it. But I think it's just a good practice to just ground the input on everything. So I just tin the tip a little bit every time before I start soldering. And if it looks a little funky, I might tin it again. Let's see. Now I've got this little shape that I bent this resistor, 0 ohm resistor into. So it's a little bit longer leg on one end, and I'll just put that on the foot switch. And this is bypassing the circuit, so your signal is going through this resistor that doesn't resist, and bend it in place. To be kind of quick with these solder lugs on the foot switch, because they don't really like heat. The epoxy that holds it all together is only heat resistant up until a certain point, and then it melts, and usually that's anything more than a few seconds. But I run the iron pretty hot. I have it set at about 800 degrees, so it's hot enough to melt and get everything together nicely very quickly. Next we'll do, I pre-cut these. I don't need this other piece. I pre-cut these longer pieces out of some bus wire, and it's 1 inch of bus wire, and your input and output jack signal will be going through this. I think this is 24 gauge, 22 gauge bus wire. It's pretty thin for bus wire, but flexible enough and usable for this application. Sorry I don't have a better angle for you to see. I'll have to figure that out eventually for you to see kind of what's going on at the same time. Perhaps I will pause for a moment and see if I can find a better angle for you to see what I'm doing inside the pedal. Let's try that. Alright, maybe you can see a little bit better now. So these jumper wires, this bus wire is just going between the output and where the output goes on the foot switch, and then it'll go also here to the input lug. And I just kind of bend these so that they fit nicely inside of here. My hands will probably still get in the way because I don't have small hands, but so get all these in place first and then solder them together. Also like to trim the excess off of this end first so it looks a little bit nicer. But heat the component a little bit first, or the two components that we're putting together, and then apply solder kind of to the iron, and then it flows onto the components. That's usually how I do it. Put a little bit on the iron first, and again, same thing. Not too long, but definitely long enough to see that everything is completely flowed and melted, and then just kind of check the joints in there. They look pretty good. And then just do the other side where they connect to the foot switch. This you have to be a little bit faster about so that you don't melt the contacts or the epoxy. Okay. Now I'll trim the excess off of these. And then I have a predetermined length that I use for this wire. I've already cut and stripped it just to make this a lot faster. And I'll just bend that a little bit, and it'll go into the positive terminal on our power jack. That's the center one here. That's because this is a positive ground circuit, and this is going to go to the input switched ground, so it's going to turn the battery on and off if you're using a battery. but also the rest of the circuit as well, whether or not you're plugged into the input. So if you unplug to the input, this lug goes nowhere. If you plug into the pedal, this lug connects to ground through the plug on your cable. And then when it does that, it completes the circuit and it allows for your battery to work or your power jack to work. It wouldn't work unless this is plugged in on the input. And bend that 90-degree angle, and then that little bend as well. I like to kind of bend components before I solder them, so that they've got a mechanical connection first. Everybody's different on that. Some people definitely don't like that, but this is something that's really not meant to be messed with. I can do it. It's easy enough to pull that apart. It's not, tied in knots or anything. So, but it is something that just gives me a little peace of mind that the component is um, structurally intact there. And now I'll just bend this wire kind of out of the way here and tuck that in there, and it's kind of pushed all the way against the inside wall here so that it's out of the way of everything else. So this part of the wiring on the box is done, and next we'll do the circuit board, and then the circuit board can go into here and we'll wire the rest of the connections. But let's do the board next. I'll talk to you a little bit about the components and measuring all that before it goes on the board. Here's everything that's going to go on the board. You've got your transistors, capacitors, resistors, and the two trim pots. It's a pretty simple circuit, but that's kind of why everything really matters a lot on this circuit. The caps are all old stock, so I've gone through and I've measured all of them first. I've got this little box. There are several ways you can do this, but I've just got this one that will measure the value of the capacitor. But I've gone through and measured to make sure that they were within spec, and they're not. Kind of odd or weird value, even though what it says is one thing. That does happen a lot on old electrolytic capacitors, especially. But film caps too, depending on the type, can start to read higher or lower value than what they really say they are. There's a little bit of an order of operations when I'm doing this, but usually it's kind of the same as when you're assembling anything really. But usually I'll do the trim pots first, then resistors, then capacitors, then transistors. So it's kind of small to big. But yeah, let's do the assembly now. So the trim pots. The first thing is our input trim. They're labeled on the board, so if you open this up, you can see which is which. The input trim is a 50K trim pot, and what it does is it puts a little bit of resistance on the input of the signal before it hits the circuit, before it hits the first transistor, and that kind of helps. It can clean up the fuzz into something more like an overdrive or like a dirty boost, but it can also help eliminate some of the low end kind of flubbiness, um, and just be a little bit more friendly with higher output pickups. It's kind of a really fun control, to be honest. It could easily be on the outside of a pedal, but I wanted to make all of these pedals just really streamlined as far as the outside controls, so it's really just like plugging into an old two knob fuzz. But it is really useful. I would probably recommend when you get the pedal to just adjust this trim, the input trim pot, wherever you like it. So it depends on maybe the guitar or amp or however you're using it. But I'll usually preset them a little bit dialed up, like maybe about a quarter of a turn, a quarter of its rotation up, so that it just knocks a little bit of the kind of fatness of a fuzz face um, out. So it's just not quite as boomy sounding. It's a little more focused. But you've got movement to go in both directions. You can go higher gain or lower gain and kind of move that around as you prefer. The other control is the bias for Q2. So on the test box, that was on the right knob, potentiometer on the outside, and this one is just on the inside. It's a 25K pot, so it's got a wide sweep that you can adjust. I'll usually set it kind of in the middle first, and when we plug it in, when we bias it, um, when it's all done, we'll just fine tune that where it needs to go. This out of the way, and resistors are next. So there's a funny little resistor all by itself on the side here. It's a 100K, and that's just like on the original fuzzface board layout. It's kind of over here by itself, and it's a feedback resistor, and it's taking some of the signal from that's going out of Q2 and putting it back into the input of the circuit. So it's kind of similar to anything where you get like a negative feedback loop, like amplifiers have them, but it kind of helps stabilize the circuit a little bit, and you can adjust the gain of the circuit a little bit with that as well. But this is stock value. It's 100K. You could do this a lot faster than I'm doing it right now, but I'm kind of trying to explain a little bit of what I'm doing. And I also like to kind of straighten things out a little bit so that they look neater. Let's see, the next one we need is Q1 bias. So this is 27K, a little bit smaller value than the stock 33K, but it gets us in the right window for voltage to sound right and feel right. It kind of, especially that Q1 voltage, changes the feel of the fuzz considerably. When you're playing single notes, especially, you'll notice kind of the right compression under your fingers when it's in the right window of voltage. And the last resistor is just for the LED on the bottom here, just so that the LED doesn't burn up when you turn it on. So it limits the current going to the LED. You can adjust the brightness depending on the value of resistor you use there. I use somewhere kind of in the middle, but I'm using these flat LEDs on all these, and for the most part on everything in my lineup now I'm using those. I like how they look. They're not very bright too, which is nice. They're bright enough to see in really any situation you would need to, but they don't blind you. Um, they also kind of with this they kind of go with the artwork really well, kind of because the LED is right in the middle of that pyramid eye logo. It illuminates kind of in a circle. So it looks like an eyeball. It's pretty fun. So resistors are all in. Cut all the excess off. I'm usually looking at both sides of the board as I solder it. I want to make sure I get a little pooling of solder on the top and the bottom so that it looks right, and so it's not kind of, I don't know, blobby and bad. But if you work pretty fast with a hot soldering iron, it usually goes pretty well. And these solder pads are also a little bit bigger than you would find on a lot of circuit boards. So I think that helps a little bit to transfer heat and make that work a little bit more effectively. So next we'll do capacitors. Got to bend these a little bit, and I've kind of just use these little pliers to hold it still. I gotta figure out what do I want people to see if they open this. Usually the logo. I kind of like the logo on this one. This Rifa logo looks cool. So I bend it so you can see that, and you can see a little bit of the value also, which is sometimes a good idea. This one says 22 microfarad right here. Probably can't see it very good because it's very small. These are polarized capacitor. This is a polarized capacitor, and so is the input cap. So they need to go in a particular orientation. So if you're building a pedal and you're you probably know this already, or at least you know to look for it. Make sure your polarized caps are in correctly. The input cap might not matter as much. It could be a little bit noisy. Or as far as you do want to do it right, but as far as the function of the pedal, it might not matter as much as this bypass cap, what we just put in there. That really won't work. It needs, in this case, positive ground. It needs the positive end to go to ground. And if it doesn't, it'll be it won't work right, and in this case, the fuzz will be very low gain. Put the input cap in, and the last one is our output cap. And yes, if you're wondering why sometimes it takes me a long time to make your pedal or pedals, this is why. Things are just, I like it to look nice, and I want it to be sturdy and last. So I take my time a lot of times with these just to make sure that they're perfect. And hopefully that's appreciated. So solder these in place. The thicker leads on some of these capacitors, you really have to leave the iron on a little bit longer to get it heated up, which makes sense. It's something to consider if you're doing this on your own. All right, now the other two, I like to kind of check to make sure they look okay before I do the other side. Sometimes if they're a little bit crooked, you can move it. When it's only soldered on one side, you can move it a lot easier. But all these look pretty good. You should, of course, be careful touching all of this after you solder it, because it will be hot. I've mostly gotten used to burning myself, so it's not too bad. All of these look good. The last components that will go in here are the transistors. I've marked them on the top here with a little bit of Sharpie. So you've got 1 dot for Q1, 2 dots for Q2, because they look the same otherwise. Let's see. So if you look at the transistor from the bottom, a lot of times they'll be offset a little bit. So on this one, the transistor legs are offset. This middle one is a little bit farther down on the body, but they're also marked. So this one has a red dot, which is indicating the collector. On my circuit board, it has the emitter as a square solder pad. So you just need to put that in the right orientation. Q1 is here up top, and it's going to fit that in there neatly, bend it over so that it sits there nicely, and I'll solder just one leg in first. Make sure it looks nice and neat, and it does look pretty nice and neat. You have to be a little bit quick. It's harder to damage these than maybe one might think, but I definitely try to be quick with my iron on transistors, just in case. So, same thing. Line up the collector with where it should go with that red dot, and then bend it over. And once they're on the board, they'll kind of fit just right up next to each other like that, which is again kind of reminiscent of the old FuzzFace design and how they look, which I like. As far as the circuit board design is, the rest of the build is really pretty modern, but I just like a little touches that are kind of like little nods to the originals. These will certainly be more consistent than the originals. They tend to be um, all over the place as far as how they sound, but that's pretty normal. Just because it's a pretty delicate circuit, and if you wanted to make them all sound the same, you'd have to really work at that, and you'd have to really spend some time dialing in transistors, and you'd have to find some transistors you wouldn't use, and I'm sure they wanted to use up everything that they could when they were making these when they were new in the 60s. Nowadays, possibly more is expected of us. We want kind of the best version of a fuzz face every time. So that's what I try to do. I'm just going to go over a couple of these solder joints just to make sure. The middle ones I kind of just tacked down, so make sure they have enough solder in them, and those look good. Okay, just cut the legs off that have been attached to these transistors for a very long time. And they're now a fuzz pedal, just as they were always destined to be. These are really great sounding NKT transistors. I really like them for a lot of different things. They're great in a Mark 1, Mark 1.5, Mark 2, really anything where you just need the classic germanium sound. They tend to be really consistent. As far as the specs of the gain and leakage, um, there seems to be at least a tighter spec on it. It's not super high gain, so it's ideal for a lot of these old circuits. It's in the right gain range. There's kind of three types as far as I can tell when I'm measuring them. There's some that are very low, below 40 HFE, and they're a little bit lower leakage. Then there's kind of these 70 to 80 HFE medium leakage, and then there's kind of above 100 to about I would say 130 HFE. There's always going to be outliers where there'll be some that are just really, really high or dead or very low HFE, and sometimes there's some that are just very, very high leakage. But for the most part, they're very consistent, so I enjoy using them. And they're still pretty easy to get, so they're not crazy expensive. But they sound great. So next, we'll just do the wiring that comes off the board. I've pre-cut all of those wires, so they're just right here. I usually do that just to kind of speed up the build process. Most of the time I'm making more than one of these. So I'll be cutting and stripping hundreds of pieces of wire at the same time. They do make like machines for that, but I'm just making them by hand. So I have a weird little process of doing this on the bottom of the board, and then just moving the wires up into place where they go. I do that for a couple of reasons. Just number one, it looks really nice and clean when it's done, but also it keeps the top from getting solder flux on it, so I don't have to clean that part when it's done for it to look clean on top. There's a little bit of flux on the bottom, but no one will ever see that, and it'll just live there. Lastly, the other side of the board will get same thing, but just two wires. There we go. And one of them is a little bit shorter because it doesn't go as far. This one grounds the circuit to the output jack. The short wire there. There we go. Building pedals is very zen, so if you want to get into something that's relaxing, building pedals is a fun thing to do. Well, it's fun eventually once you learn kind of what you need to do and kind of the ins and outs of everything. But um, when you do, then it can be very relaxing. So the board itself and all of the off-board wiring is ready to go, and then we'll just we'll get this inside the box, and I'll try to get a better angle so you can see how that all goes together. We'll do that now. Now I've got the pedal assembly and the board assembly, and we'll put the two together. I just bent up these wires coming out of the board, and this is the power one that goes to the power jack here. So that's going to go under everything. The other ones go over, and we'll just line up all the pot lugs with the PCB holes. Here we go. It's all fits neatly in there, and then we'll just put the LED through the hole. Let's see, I'll move these wires down here so we can get the iron in here and we don't accidentally melt those. And we're going to solder the board connections where they join up to the pots. Those pot covers that I put on the pots before keep the bottom of the board from shorting on the pots if it were ever to bend over and reach it. They don't quite reach the back of the pots, but just in case. Do kind of both ends first so that it's square, and just kind of look at it. Okay, it looks good. And we'll do the other pot lugs. That all looks good. Now we'll do the LED. In order to get it flush with the outside, you can see it's kind of sticking out a little bit. I just put a piece of tape between the LED and the enclosure outside so that it sits flush, and then solder that in place on the top of the board. We'll have to clean this part of the board. That's okay. I'll also use that as an opportunity to take these little marks that I put on the transistors to tell me which one's which. I'll clean that off with just some flux remover. So that's good. The LED is nice and flush on the outside, and the board looks straight inside here for the most part. Yeah, there we go. Then I'll just run these 5 wires where they go. So the first wire is the power. This is technically ground, or like what you would call ground on a normal negative ground pedal, it's going to the negative terminal on the power jack. But because it's positive ground, the negative side is where the circuit's power comes from. Alright, so that's neatly I kind of tuck it to the inside of the board there, or inside of the enclosure, so it's out of the way as much as possible. And then we'll do, the next wire is the input wire. So that's here. That's going to go to the foot switch. I've cut and sort of predetermined the length of all these, so I don't need to strip them or anything like that. Once they get in the box, they're ready to go size-wise, which helps a lot. Kind of just have to build one and then figure out how long they need to be. Turns out most of them can be the same length, and then just a couple of them need to be shorter. And then what I do is I'll mark it on the mat here that I use that has sort of inch increments. I'll just mark a couple of spots so I know kind of how long it needs to be without really measuring. I can just look at the line that I marked. I'll put, let's see, push that to the side. The next wire comes off of the board is for the LED. So it's the other side of the LED current limiting resistor. There's one that's attached to the LED itself. The other side comes off and it goes to the switch, and then the switch connects that to ground, and then that illuminates the LED simultaneous to turning the pedal on, so making it connect to the ins and outs of the circuit board instead of this resistor here, or 0 ohm resistor. I've explained a little bit more of this in some other videos, but I do want to do one on just kind of all about basic ins and outs of pedals, sort of like pedals 101 as far as how switches work, jacks work, how power works, just things that would be helpful to a beginner learning how to make pedals, and maybe just slightly entertaining to or relaxing to watch. So tuck this wire under there, and then our ground wire is going to be next. So it's coming off of the board, this wire. It's going to go to the ground lug on the output jack. Put that down here. I can kind of push that back and out of the way a little bit. There we go. Lots of little bending things that you have to do when you make pedals, and it's even a little bit trickier when you're working in kind of a smaller enclosure, for me anyway. The jacks, this is a big piece of metal, so you usually need to heat that up a little bit longer than something like a component lead. So it's nice to have wire that doesn't melt, but kind of hard to find sometimes. This is a wire from Love My Switches, where you can also get those rocket sockets. So I like their, it's pre-tin wire, and it's kind of moldable and flexible in a way that I like. It stays where you put it, and not crazy expensive. You can buy it in bulk. That helps a lot. It comes in a bunch of colors, but I just usually use black just to keep it sort of like the wire's not even there. Hopefully, ideally, I want to look in the pedal and sort of think, like, sort of look at it, and there's the least amount of parts possible, or like just the simplest looking possible, minimalistic look, I suppose, is what I like to see in my pedals. So everything's kind of pushed to the side for that reason, so that when you're looking at it, they're just down here in the side, but out of the way visually. So all of the board wires are in now. I'm going to do kind of the foot switch ground. I'm trying out a new way to do this, so bear with me here. Just as far as how I route the wire anyway, a little bit. I would like to be able to bend it so it stays in place a little bit better, and I think that's going to work. Mainly before I solder it, this stays in place, kind of just like that. That's kind of nice. And I think sometimes the way it solders just looks a little bit cleaner. That looks pretty good. So that one's going to ground, and it's just basically going to ground this middle lug on the foot switch that we haven't done yet. And that will either ground the input of the circuit when it's off, or it will ground the LED when it's on. So it's kind of a dual purpose, but just one little wire, but very important. This one I don't have a length predetermined yet. Still kind of experimenting with how that construction of that is going to go. But so far this is looking pretty good. All right. So we're almost done soldering. There's a couple more steps after this, which is mainly got to clean up the board. It's got a little bit of solder flux on it that I would like to remove so it looks a little bit nicer. And then you could leave it there, but I just think it would look nice if this was all clean. And then we'll have to obviously test it, make sure it works. But I'll still need to bias Q2 with this trim pot here. And then I'll set the input trim to where I think it sounds the best with this set of transistors. You could adjust this on your own, either one of these. You know, if you own this pedal, you can put it wherever you want. You can use your ear a little bit on the bias. You can also use a meter, which I'll show you how to do in a minute, to get the voltage kind of just right on as far as what I like or what I think they should be. So this is just a little nylon tie down that you can buy on Amazon, and it will give you a little strain relief. So when you're pulling this out to put a battery in it, if you decide to do that, it doesn't strain this side of the wires where they're meeting up to where they terminate, which is on the power jack. So I'm going to tuck that out of the way, and then we're going to do the red one first. And it just goes down to the switch lug on the power jack. There's a tight squeeze in here now, so I tend to use little pliers to hold the wire now. My hands are a little bit too big. And I just pull it back, hopefully enough to where it's still on there a little bit, and then I can twist this end and it'll twist up the wire. It's a little bit easier to do it that way. You can see that. Than it is to twist up bare wire. You've got something to grip. And then I'll just tin this because the wire on the battery snaps. It's not tinned or twisted, so it needs both on the end that you strip back. Bend that out of the way. Hang on. Trying to do that so you can see it, but it's easier to do it with it flat. But I got that one in there. And last wire to solder. I'm going to tuck that so that it looks nice in there and trim that to length. and do the kind of the same thing. Strip back some wire, but we're going to pull it just enough off of the wire, not all the way off of the wire, so it leaves it exposed a little bit. Let's see if I can. That's where you can see it. It's exposed a little bit, but then you can grab the outside of the wire and twist it as you're pulling it off, and it will twist the wire up nicely. Okay. Tin that. And this goes right next to, so I didn't solder that wire that comes off the board to the negative terminal power jack lug, but we're going to do that now because those two are hooked up together. The battery black and the board, since this is positive ground effect. There's no charge pumps or voltage anything in here as far as converting the voltage from negative to positive ground. It's just wired up kind of old school, and you have to use an isolated power jack or an isolated power supply. If you don't use an isolated power supply and you're using a few effects together, it will make everything not work that's hooked up together. So you want to make sure it's isolated if you're using a power supply with these pedals, and quite a few pedals like it. But if you're just using a battery, it doesn't matter. And if you're just using this by itself, it wouldn't matter what kind of power supply. But usually, sort of the nicer isolated power supplies are quieter power anyway, so it's a nicer sound to use a nice quality power supply. Next thing I'm going to do, just make sure that these are tight, because I didn't tighten them all the way. I guess I needed to move those around a little bit. Those are nice and tight now, and then we'll install the knobs, and we'll take it back over to the test area and make sure it works, and then we'll set the bias, and should be ready to go. I'll have to come back and clean this up a little bit, but other than that, it should be pretty close to done, but let's go do that first. Got everything plugged in, power, input, output, and we'll just turn the fuzz all the way up and turn the volume up about halfway or so, and we'll just see if it works. First, the LED turns on, which is a good sign, and it turns off, which is also a good sign. Next, I'll just turn the attenuator up here a little bit on the aux so we can hear it in the room. We'll just see if it works. It's really quiet, but I want it to clip the microphone. Looks like. Looks like it works. We'll have to set the bias now, so we'll leave it plugged in. We'll just flip it upside down. You can see this better. The bias is here. On the left side, it'll say it's labeled right here, bias. I'll just take my voltmeter, my multimeter, just the same as before, set to DC volts. Well, this is positive ground, so I'm taking the positive end. I just put it in, you can see this better. I'll put it here. I just put it in the enclosure where the screws go. Then you don't have to hold that on anything. And Q2 is just down here. And this is the collector. So we're at 5.16 volts with it set close to the middle-ish. If we go this way, voltage goes up, which is not what we want. But it is a sound, so feel free to experiment. You can turn this either direction. If you have a multimeter, it's easier because then you can tell kind of what you're doing easier. But if you just use your ears, there's kind of a sweet spot in the middle here where it evens out. It starts to get compressed and fuzzy, but not overly so, and it cleans up well still. I like to set it around 4.55-ish volts, so a little bit over 4.5. That should work. We'll play it a little bit and just make sure that that's okay. The input trim is something I want to show you on the video, just kind of what it does. So what I'm going to do is I'm going to switch over to the aux, and then you can hear a little bit better what's going on. But I'll go ahead and play it just as it is a little bit, and then I'll turn the input trim. You can kind of hear what that does to the whole circuit. It changes it considerably, in a good way. I think it could be useful for somebody who's using, like I said, kind of hotter pickups, or they just want a little bit cleaner sound out of it. I'll preset them a little bit turned clockwise, so you can still turn it counterclockwise to get a little fuzzier, or a little bit less so turning it clockwise. So let's do that now, and let's see what it sounds like and mess with the input control. Now I'll show you the range on the bias trim pot. You shouldn't really have to mess with it. If you want to, though, you're more than welcome to adjust. If you want to get it set exactly where it was, you can take a picture of it, or you could draw a little line across it with a Sharpie or a piece of tape or pen or something, just so that you can get it back to stock. But you could also use the meter, just like I showed you. I'll play and we'll turn the bias pot so you can hear how that changes the sound. So you can hear in the clip just how important the bias setting is. To the left, it became very spitty and aggressive, and a lot louder, and just very different from just a regular fuzz face sound. As you turn that towards the middle, that's where your typical fuzz face tones live, and it just becomes more compressed the more you turn that up. And as you turn it all the way up, it starts to gate the transistor, so you can get some gated fuzz sounds with that. But really, both of these controls are really meant to be kind of a set and forget. So you can dial in your classic fuzz face sound in your setup and how you like it, and then just use the controls on the outside like you would on any fuzz face. Thanks for watching the video today. If you have any questions or anything, just let me know. If you missed the sale on these, just send me an email because I may be able to make another one. As long as I have parts, I can do another one. But yeah, the NKTs are just something a little bit special for this run. So I wanted to share that and just share the build process on the face model in the Lineage series because I haven't done that yet, and it's pretty fun. So yeah, I hope you enjoyed the video. Leave a like, subscribe if you can. Anything like that is super helpful. So yeah, I hope you have a great rest of your day, and I'll catch you next time.